obtain equation of motion for motion in plane with uniform acceleration. Consider u bar is the initial velocity of the object at initial time, that is at t is equal to 0. After some time, v bar is the velocity of the object that time, which is equal to t. Now we know definition of acceleration is change in velocity upon change in time, which gives v bar minus u bar upon t minus 0, which is equal to v bar minus u bar upon t. By rearranging this equation, we get v bar is equal to u bar plus a bar t, which is first equation of motion, which is similar equation which we have obtained in rectilinear motion. But remember, in this equation, v bar, u bar and a bar are vector quantities. Now s bar is equal to displacement of the object from for time t is equal to 0 to t. Here average velocity is equal to initial velocity plus final velocity divided by 2, because acceleration throughout the motion is constant, therefore we can calculate average velocity like this. Also we know velocity is equal to displacement upon time, therefore displacement is equal to velocity into time. By substituting value of average velocity, here we get u bar plus v bar upon 2 into t. V bar can be substituted as u bar plus a bar t, which we have obtained in first equation of motion. Now by calculating this, we will obtain second equation of motion for motion in plane, which is equal to s bar is equal to u bar t plus half a bar t square. Now these two equations can be resolved into two components. First equation, v bar is equal to u bar plus a bar t. This equation can be resolved into along x component, that is vx bar is equal to ux bar plus ax bar t, and along y direction vy bar is equal to uy bar plus ay bar t. Similarly, s bar is equal to u bar t plus half a bar t square, resolved into two components. Along x axis, it can be written as sx bar is equal to ux bar t plus half x bar t square, which means displacement of the particle along x axis and displacement of particle along y axis, that is sy bar is equal to uy bar t plus half ay bar t square.